Welcome back to the Programmer Guide YouTube channel. Today we are going to discuss about the solid principles in Java. See, in the anybody can crack Java interview. It is the very important question, and by using these solid principles, right, we can develop scalable and reusable software components. Okay, see, in this video I'm going to explain about the solid principles with real-time examples and its advantages. Solid stands for, there is a 5 different design principles are there. One is the single responsibility principle, open close principle, isco substitution principle, interface segregation principle, dependency inversion principle. See, these solid principles are very helpful to develop and design the better software components. Okay, so these solid principles are software design principles. It enables and manage the most of the software design problems. Software designs more understandable, flexible and maintainable. These are subset of many principles promoted by the Robert C. Martin. Actually, this Robert C. Martin is the founder, author of the solid principles. We will see each principle with in detail. Okay, single responsibility principle. See, by title itself, it is having the single is nothing but only one. A class should have one and only one reason to change, meaning that the class should have only one job. Suppose, right, if you take the example, there is a multiple reasons if you want to change the class in that time, right? It is very difficult to test each and every module of that object. Okay, so every class or module should have responsibility of over single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class. See, the main objective of single responsibility principle is, if class have only one reason to change, that means one functionality, then it is very easy to maintain and it is very easy to test, and it is having flexibility and extensibility. If you want to add any new features and upcoming softwares, right, in software there end users or business owners might need to extend their features. So if there is only one reason, right, we can add the extensibility of the current feature. Okay, and the parallel development. Suppose if it is having the single responsible, then other components individually we can develop each and everything. Okay, so that means there is no dependency between the each and every module of the project, so it is very easy to implement. Okay, and loosely coupling, there is no dependent features, right? So since it is very loosely coupled, this is the main objectives. So we will see the example how it has been implemented. See, single responsibility principle. In the single this is the not a single responsibility actually. See, there is a few methods are there in single in this class. Okay, like account login, okay, and account registration, account check balance, account fund transfer. These are the 4-5 responsibilities are there. In this case, what will happen now? If you want to change something, you need to test entire application. So it is very difficult to extend the code. Okay, it will cost lot of time. Okay, so instead of that, right, each and every class like account login should have one responsibility, registration class should have one, and check balance, okay, and fund transfer, each and every one should have single responsibility. In that case, we can easily implement and extend these features of the application. Okay, so now we will see the second principle, open close principle. The open close principle states that software entities, that is nothing but classes, modules and functions, should be open for extension but closed for modification. if any new functionality should be implemented by adding the new classes and attributes and methods instead of changing the existing functionality. So we will see the example how it is going to be work. See, in open close principle, see here we are having the fund transfer. Okay, see, fund transfer is having the method fund transfer dot nifty transfer. Okay, so suppose, and also we are calling this nifty transfer by using the class reference in static method. See, this fund transfer is the generic method. Okay, and it is having also IMPS fund transfer, RTGS fund transfer. Suppose if we implement the IMPS funds transfer to funds transfer class, right, we can use the fund transfer mechanism and we will change the few business logic instead of changing the current behavior of the nifty transaction. So in this case, right, we no need to test the fund transfer. We will test only the IMPS fund transfer and no need to make any changes in the fund transfer. Here fund transfer is extending. That means software components are open for extension and closed for modification. We are extending the IMPS transfer. So it has all the features of IMPS transfer and nifty transfers. Okay, and if you want, right, specifically you can use the fund transfer also here. So in this case, in this way we can implement the open close principle. It is always talks about the inheritance. If you are not following, we are ending up testing in entire functionality. Suppose if you are implementing the same nifty transfer and based on the conditions like IMPS transfers and RTGS transfer or UPA transfer and future some light transfers also implemented. So in that case you need to test complete functionality. So QA team need to test entire flow. It costs to the company maintainability issues due to large and overhead of the classes, breaks the single responsibility principle also. Okay, so this is the open close principle. Now we will see the another important principle, isco substitution principle. See, in overall solid principles, isco substitution principles having the most difficult one to understand. Okay, isco substitution principle applies to inheritance hierarchies such as derived classes must be completely substitutable for their base classes. I can simply put here, like, if class A is subtype of class B, we should be able to replace B with A without disturbing the behavior of our program. Sorry, derived classes should be replaceable with base classes. It extends open close principles and also focuses on the behavior of superclass and its subclasses. We should design the classes to pursue the property unless we have the strong reason to do otherwise. See, I have created the one car factory that is turn on the engine, accelerate and brake. Suppose whatever the car is there, right, we need these minimum features. Actually I'm creating the motor car. It implements the car functionality. So here, right, turn on the engine. So to turn on the engine we need a engine object. So I have created the another engine object which is having the different methods like power on and apply brake. Okay, if you see, right, turn on engine dot on engine. So it is the creating the object of motor class. Okay, now suppose if you want to create the new object. Okay, new object is nothing but new electric car. Okay, suppose if you want to create the electric car, in this electric car if you implement this, okay, so it is all together new functionalities, engine and turn on the engine, accelerate and brakes are going to be same. Inside that, it is going to have the different set of new, altogether new mission we have going to prepared. So in the same way, if you go to the car factory, right, derived classes are substitutable with base classes. See, if you see this object, right, car C is equals to new motor. By using the car object, you can create any new car. Here I created the motor car and electric car. In future, if you want to create gas car also, you can create, and a diesel car, petrol car, specific engine types you can create. Okay, this is the way how we can implement the LISCO substitution principle. And next principle is interface segregation principle. This interface segregation principle states that larger interfaces split into the smaller ones because the implementation classes use only the methods that required. Suppose we should not force to the client or implementation classes methods that they do not want to use. Okay, we should not force to client to use the methods that they don't want to use it. Okay, here your main goal is to focus on avoiding the fat interfaces and give the preference to many small client specific interfaces. You should prefer many client interfaces rather than one general interface. On each interface should have specific responsibility. Let me go and explain how it is going to be work with example. Okay, I am taking the one bank. Okay, in bank there might be so many functionalities might be there: login, check balance, withdraw money, deposit money, fund transfers, credit cards. Each is having going to be have the functionality. So okay, suppose, right, if I want to implement the login functionality of the class, see, the compiler will says add unimplemented methods. Whatever the methods are there, right, all methods need to be added forcefully to here. But my functionality is going to be login functionality. Okay, I need to implement. Suppose if I want to add credit card functionality, let me add credit card functionality. Class credit cards implement bank. See, now I want to implement only credit cards, but bank interface forcefully, yeah, interface is correct, right? Yeah, this is forcibly implementing all unimplemented methods, but I want only this last method to implement. Okay, in this case it is a very hard to implement all unimplemented methods. To avoid such kind of situation, instead of creating the fatty interfaces, we need to create the small interfaces like this. Okay, like interface bank one, like login, check balance interface, and withdraw interface, depository interface. See, whatever the class is there, suppose deposit class is there, class deposit implements interface deposit money. Okay, so here I no need to implement all other functionalities. If I want, I can create an object of this interface and I can use it. Okay, here I'm going to implement only deposit money class interface. Okay, this is the yeah, so like withdraw also, yeah, capital required. See, such a way. So interface segregation principles that says that if you want you can implement, otherwise you no need to implement forcefully. Okay, and last principle we are going to explain, like dependency inversion principle. The dependency inversion principle states that we must use the abstraction, that means abstract classes and interfaces, instead of concrete implementations. That means high level modules should not depend on low level modules, but both can or should depend on the abstraction classes, because the abstraction does not depend on their detail, but details depends on the abstraction. The principle of dependency inversion refers the decoupling the software modules. Let me go through the example, you can understand betterly. Now I'm going to take the database connection. Okay, each and every day we are going to use the database connection in our real-time programming, right? So database connection and having the method connect, and I want to log into the system. See, whatever the system I want to log in, right, my username and password might be already registered. To connect to the database, I'm going to use the login system in one more object like database connection and login system. Here inside the constructor, each and every time I need to create the new database connection. In this case, two database objects are going to be created. It is nothing but it is a strongly coupled. So what is the fault here? I'm going to explain now. First, the database connection is the low level design module, while the login system is high level, but according to definition of the D in solid, which states the depend on the abstraction, not on the concretions. This is the concrete class, not a abstract or interface. Okay, so this snippet about violates the principle of login system class being forced to depend on the database connection. So it is a strongly coupled. So if you want to decouple this, we need to create the data source. So suppose, right, in this case, if you want to use the different set of databases, suppose one of the application uses the in one region MySQL database, another region Oracle database, another region MongoDB, and that case this implementation is going to be failed. Okay, so now I'm going to create the data source, the database connection interface, which is having the connection method. So in this connection method, whatever the implementation you want, you can implicitly implement here. In the data source class, implementing the database connection, and implementing the connection object here and returning the connection. See, whenever I'm logging into the system, I'm creating the data source object and passing the constructor object, and constructor is going to be create the only one object instead of creating the multiple objects. Okay, in this way it reduces the decoupling of the software objects. Okay, if you want multiple software database connections, you can easily implement on a single system. That means, suppose, right, one of the module wants to connect Oracle database, one of the module wants to connect MongoDB database, and that case easily you can connect, because we are depending on the abstractions, not the concrete classes. I hope you understand the solid principles. Now we will see the advantages of the solid principles. The solid principles reduces the dependencies so that a block of code can change without affecting other code blocks. The principles intended to make design easier and understandable. By using these principles, the system is maintainable, testable, scalable, and reusable. It avoids the bad design of the software. These are the most important principles in the software design in Java. You should aware closely each and every principle. If you like the content of the video, please like and subscribe my channel for the future videos. Thank you very much for watching this video. Take care. Bye bye.